we're going to work two example problems, excuse me, from section 7.5. So I've already drawn them up here. On this one, what are we asked? I'm sure just to find V. So we want to find the step response of the voltage across the capacitor. So step one, find our initial value. So we want to find our V of 0. All right, so our switch moves at time t equals 0. So before that, the switch is here. So when t is less than 0, we have, going to do a real quick drawing here. Capacitor looks like an open in DC. So we have this circuit, right? Switch is in this position. This is 12 volts. There's no current flowing through here because there's a big hole. Current can't get through a big hole. So our voltage is 12 volts. So V of 0 equal 12 volts. Then we need to find our final voltage value. So it's T much, much greater than 0. So away from the switching point where things have chilled out. All right, what do we have for that? Well, the switch is in this position. So we've got 4 volts. Again, now we're in DC. This looks like an open. No current. So our V of infinity is 4 volts. Found our initial, we found our final. Now we need our tau. Tau equals RC. And for that we use after time 0. So it'd be this half, where our R is 2, our C is 3, so our time is 6 seconds. And now we just need to plug everything in. So V of t equals V of infinity, 4, plus V of 0, 12, minus V of infinity, 4, times e to the minus t over tau. And we can just make this look a little bit nicer. Say 4 plus 8 e to the minus t over 6 for t greater than 0. That's not very good t, but that's okay. And add a volts. There you go. There's our answer for that one. All right, let's take a look at this other example problem here. So we want to find, again, the voltage across the capacitor. So let's find our, no, let's not. Our initial value is actually given to us, right? Right there. So we don't need to worry about that. We do need to find our final value, though. So find our V of infinity. So our source is 6u of t. So we're going to assume that we're far away from 0 and that we have a DC circuit. 6 volts, resistor, 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 voltage. This is our V of infinity. So this one isn't quite as easy, right, as that one, where we could just look at it and say what it is. But it's still not terribly difficult. So let's look at what we got here. This 10K resistor has a dangling in. It's poop. Don't care about it. That means the V of infinity is the voltage right across here. Voltage division is our easiest way to get there. There are many others, though. 40K over 40K plus 20K times 6 is 4 volts. So we have our initial, we have our final. We need to find our tau. What does tau look like? Well, we're going to need to find a R-thevenin, an equivalent resistance, right? So what resistance does this capacitor see? This one's a little bit trickier. So we need to find, it's a Thevenin resistance is what it is, but an equivalent resistance. So when we find our Thevenin, thinking back to chapter 4, I think, we need to deactivate the source. We have 20K, 40K, 10K, and we want the R-Thevenin looking N, because we want to know what resistance does our capacitor see. Well, what do we have there? We've got 20K and 40K sharing the same two nodes, meaning they're in parallel, and those two in parallel is then in series with our 10K. So we have an R-Thevenin that's 20K in parallel with 40K in series with 10K. So we do the parallel first. That gives us, I don't know what that gives us, but the whole thing is 70 over 3 kiloohms. So now our tau is RC, 70 over 3K. Our capacitor is 3 micro, or we get a tau that's equal to, let's see, 70 milliseconds. Now just plug it all into your V equation. I'm going to switch markers just because it's getting a little cluttered over here. Now I have V of t equals V of infinity, 4, plus V of 0, 1, minus V of infinity, e to the minus t over tau, 70 milli. So if I write that a little bit nicer, get 4 minus 3e, I went ahead and used a calculator, minus 14.25 t, and this is volts. And instead of writing t greater than or equal to 0, since we used this terminology, we can just add that in. So say times u of t. There we go.